Hello and welcome back. So we have seen how resampling techniques help you in choosing the best model, selecting the best model without touching the test set. We have used k-fold cross validation where we found that the third degree polynomial is the best algorithm which actually understands the pattern well on the salary prediction dataset. We have seen that the fourth degree polynomial is overfitting because it was giving good accuracy on the train set, and the error on the test set is actually on the raise, right? Or the cross validation set is on the raise. So we have found that third degree polynomial is the best, and we built a model and we achieved 98% accuracy. So there are other resampling techniques which will be useful in different kinds of data sets. If you look at the holdout data set, right, this is it splits 20% or 10% into a cross validation set on the train set and takes the rest of the data set as train set and builds model. If you have to choose an algorithm between linear regression, second degree polynomial and third degree polynomial, best algorithm between these three, you need to build three models on the train set, and on the holdout data set you need to test, and there will be three scores, three train scores and three cross validation scores. You will choose the model which gave you the highest accuracy, at the same time highest accuracy on both train set and the cross validation set. At the same time they should be close, right? Generalization. And then you test it and test it, the model will generally work. So the evaluation error on the holdout data to check if model is overfitting. So if we split the data, train set itself, to two pieces and try to train it on train set and do it a class validation on class validation set to see whether the model is overfitting or not. Okay, so holdout data set generally works well when the data set is kind of decent size, maybe around 10,000 to 20,000 records. Right? If the data set size is too small, right, it wastes the cross validation data set. The cross validation data will be taken out from train set, right? So pattern recognition may become a bit difficult for the algorithm. And if the split is unfortunate, when the split is happening, it is kind of sampling, right? If the sampling on the train set is not proper and the data set is small, right, the algorithm's learning is going to be not good. So these problems are there with the holdout data set. And there are other techniques like k-fold cross validation we already have seen, where the data set is going to be split into k pieces, and it takes k minus 1 pieces to train and the kth piece to test the cross validation data set. Like that, it will actually do k runs and take an average of the cross validation and the test set for each algorithm. If you are doing linear regression, it will do k number of runs and take average of the cross validation and train. And if you are doing second degree polynomial, again k runs, take the average. So third degree k runs, fourth degree k runs, like that. And it chooses the best average scores which are close and high, the cross validation and train. That is k-fold cross validation. We have seen an example also. Cross validate is the method to actually perform, and generally we use k-fold cross validation in most of our practical examples or in real-time world. So the next k-fold the cross validation technique is leave one out. Suppose that there are only 100 records in your data set. If you take 20% as the holdout data set, you will lose 20 records. So in that case, you should take one record as a cross validation record and 99 records for the training. If you have linear regression, second degree, third degree, for the linear regression you need to build 100 models, because one record you took as the cross validation, took 99 records to train, tested on the first record. Second record you took as cross validation, and rest of the 99 built a model and tested on the second record. Like that, you need to build 100 records. So if you have to choose between three models, linear, second degree and third degree, you may have to do 300 models. On the linear 100 you will take average, on the second degree models you will take average, on the third degree 100 you will take average, whichever gives you the best accuracy, and the cross validation and train score should be close. You will choose that as the best model. When data set is small, this works well. When you have 1 million records, if you have to build this, right, you can imagine, right, 3 algorithms, 3 million models you need to build and train and test. It's not at all suggested when data is huge. Okay, so when data is set is small, like maybe 100, 200, 300 records, you can leave one out. Okay, leave one out, cross validation technique. And then random sampling cross validation. This is a version of k-fold cross validation only. There we are splitting the data into k pieces and taking first piece and trying to use it as cross validation and things. But here you will actually choose a fraction, right? A fraction of the total data, alpha into m. Alpha is between 0 and 1 percentage, and that percentage of data is going to be randomly chosen. Random sampling cross validation. Okay, so that sample is going to be chosen randomly, and then you use those green pieces, combine those green pieces and use it as cross validation. Yellow pieces you use to train the model. Same k-fold cross validation kind of thing, but k runs you need to specify. How many runs you need to specify? The fraction and the k runs you need to specify in the random sampling cross validation. So now we use the k-fold cross validation generally. And then the next one is the bootstrapping. Bootstrapping is you take 63% of the data as the train set and 37 as the cross validation set. You keep this cross validation set aside and you choose random records from your 63% and try to reproduce 100% data out of 63%. That is called as sampling with replacement, duplicating, right? These red records are being duplicated and added. That 37% is added and made 100% records, and then we will build a model using this sampled with replacement data set and then test it on 37% data. So this is useful when we are handling imbalanced data sets. Right? In classification, if one class has got less records and another class has got more records, algorithm finds difficulty in understanding the pattern in the less number of record side. So in that case, it will be useful in anomaly detection. Anyway, we'll see it. Bootstrapping is the technique which actually tries to generate 100% data out of 63% and then tries to build a model on this sampled with replacement data and then test it on 37%. Same thing again, if you want to build 3 models, 3 times it's going to do sampling with replacement and then use that data, and 3 models it will build and take the scores, cross validation and train. Whichever is high and close to each other, it will choose that algorithm and then test it on test set. If it is working good, the model is good. So that's all about the resampling techniques and model selection approaches. Thank you.